Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abudiwa Sots Ugobela Maths. And without any further ado, let's look at these questions that we have here. Okay, so we have question 7. It says a garden worker pushes a lawn mower of mass 15 kg at an angle of 25 degrees to the horizontal, 20 meter across a horizontal strip of lawn, as the diagram below illustrates. And then just below the diagram, we are told that the kinetic frictional force between the lawn mower and the grass is 35 newtons, right? So very crucial to note there. And then note that we are also given the mass, which is 15 kg, right? Okay, then also the displacement is 20 meters, and then this is at an angle of 25 degrees. Now 7.1 says define the term conservative force, right? Now what is a conservative force? We say a conservative force, 7.1, is a force for which the work done in moving an object, between 2 points is independent of the path taken. Independent of the path taken, right? And that's basically how we define a conservative force. So note that with a conservative force, it is independent of the path taken, but with a non-conservative force, it depends on the path taken. Now 7.2 says classify frictional force as either a conservative force or a non-conservative force. Now we know that frictional force is a what? Non-conservative force, because it depends on the path taken, right? So if an object is going to the right, the frictional force will go to the left. But if the object is now going to the left, the frictional force will now go to the right. So it depends on the path taken by the object. Now 7.3 says draw a label free body diagram for the lawn mower, right? So for 4 marks, just gonna start by indicating a dot for the object, the lawn mower. And then up there we have the normal force. And then down here we will obviously have the gravitational force. Those are your obvious forces. And then we have frictional force, which is opposing the motion. Note that frictional force does not oppose the force applied, but rather opposes the motion of the object. Remember that as much as this is being pushed at an angle, the lawn mower is moving in that direction, right? So the FK has to oppose the direction of motion. So that means you cannot draw it like this, right? So a lot of you be making mistake in drawing your FK like that. Please note that you cannot draw it like that, because it does not oppose the applied force. It opposes the motion of an object, right? So your force applied, obviously, because the force is being applied in this direction, more like down here, then it's going to be like that. Remember, all the forces must come from the dot and must be outward from the dot, right? Then this is your force applied. And just like that, you have yourself 4 marks. Then 7.4 says, state the name of the force acting on the lawn mower, which does 0 work on it. Now we know that the ones that will be doing 0 work, no work done, are the ones that will be perpendicular to the displacement, right? So if we consider this to be our displacement, remember it's going to the right, the lawn mower is going to the right, then we can see that our normal force will be perpendicular to the displacement, and then also our gravitational force will be perpendicular. So your conservative forces in this case are the ones that will be doing 0 work. So it is either the normal force or the gravitational force. So either one of these two would be correct, right? So it's the normal force or the gravitational force. And then as you can see from there on, we have collected how many marks? That's 5, and then 6, 7, 8. So that's 8 out of 13. Decent marks, right? So right now, we just have to struggle with this 7.5 here. The lawnmower moves at a constant velocity. So we are given a keyword here, constant velocity. Now, whenever we see the keyword constant velocity, what comes to our mind is that acceleration is 0 meters per second square. And as a result, our F net is 0 newtons. And then as a result of F net being 0 newtons, that means W net will also be 0 joules. And as a result of W net being 0 joules, that means also change in EK is equals to 0 joules, according to the fact that W net is equals to change in EK. So if W net is 0, then obviously even your change in K should be 0. And then what else do we know? We know that forces are balanced here. Forces are balanced, right? So, okay. Now, 7.5 says calculate using energy principles the power at which the worker works if he or she mows the strip of lawn in 2.5 minutes, right? So they tried to they tried not to be too gender biased here by saying he or she. So, but then we know that the one who would be working the lawnmower would obviously be a male. Okay, so calculate using energy principles the power at which the worker works if he or she moves the strip of lawn in 2.5 minutes. Okay, so let's now consider this, right? So we have our power formula, which is P is equals to W over delta T. But then remember that here we are being asked about the force applied. If you can read this carefully, calculate using energy principles the power at which the worker works, right? The worker obviously is doing what is applying a force to the lawnmower so that the lawnmower can cut the strip of grass, right? So, okay, now understand this. That means the W here will be representing the work done by the what? By the lawnmower. So let's say work done by LM for lawnmower, right? So that means here, from our free body diagram, we could see that our normal force was just like that, and then our gravitational force facing down, and then we had our force applied here, which is the force of the lawnmower. And then here we had our FK, right? So if we wanted to calculate the work done by the lawnmower or the work done by the force applied, let's just call it the force applied, then we would just say W net is equals to what? Change in EK, right? And then here the W net will be represented by work done by force applied plus work done by FK, which is equals to change in EK, which is half M, and then bracket VF squared minus VI squared, right? Okay, but then remember that our change in EK is 0, so this is not necessary. We just have to replace by 0, right? Based on the fact that this is moving at a constant velocity. So remember, if it's constant velocity, we say our delta EK will be equals to 0. So here, the reason why we are doing this on this side and not putting 0 is because we want to calculate the work done by the force applied. So we can keep it work done by FA and then break down the FK instead. So that's FK delta X and then cos theta equal to 0, right? So to calculate, we'll say work done by FA plus FK. Are we given the value of the frictional force? Yes, that's the 35 Newton that we saw there. So 35, and then the displacement, they said 20 meters, right? So 20, and then we know that anything to do with FK, the theta, there is always 180 degrees because it does negative work, right? So now we have work done by FA, and then we simply just going to punch this into our calculator, 35 multiplied by 20, and then cos 180 degrees. So that's negative 700 equal to 0. So to calculate work done by force applied, we're just going to say 700 joules, right? Now that we have 700 joules, we can then come over here and say P is equals to work done by the force applied, which is 700, and then our delta time is 2.5 minutes. But then you will always remember that our time should be indicated in what? In seconds. So that means we need to convert this minutes into seconds. And how do we do that? It's simply just by taking that and multiplying it by 60, because we know 1 minute is 60 seconds. So if we want to find 2.5 minutes, just multiply it by 60, and then we want to find that in minutes, which is supposed to be 150. We're going to find it in seconds, not in minutes. So which is going to be 150 seconds. So 700 divided by 2.5 multiplied by 60. So when we punch that into our calculator, we get 4.67 watts. And then that's basically how we are supposed to calculate that. And then just like that, we have the 5 marks in the back. And then that means we have 13 out of 13 at this point. Right. So, okay. Nice one. Nice one. Let's see another question now. Okay, so one step at a time. One question at a time. Then question 5 says the diagram below shows a boy skateboarding on a ramp which is inclined at 30 degrees to the horizontal. A constant frictional force of 50 Newton acts on the skateboard as it moves from point A to point B. Then consider the boy and the skateboard as a single unit of mass, which is 60 kg. Right. And then ignore the effects of air friction. Right. Then 6.1 says, draw a free body diagram showing all the forces acting on the skateboard while it is moving down the incline. So if you can just allow me to draw it here. So the dot indicating that unit, that single unit of mass. And then we have our normal force, which will be perpendicular to the displacement. So our normal force perpendicular to the displacement. And then just down here, we have our gravitational force. And then obviously, because the boy is sliding down, that means we have to have frictional force that is opposing the motion. So there we go, parallel to the slope, parallel to the surface, that's your kinetic frictional force, right? And then just like that, we have ourselves 3 marks. So each and every force there will be awarded a mark. Then okay, just like that. Then 6.2 says use energy principles to calculate the speed of the boy skateboard unit at point B. Right. So at point B. Now, this is how we're going to calculate that. Obviously, with an incline, remember, I did mention that whenever you have an inclined surface, you should always think of using what? The WNC formula, work done by non-conservative force. But as you can see, this is a 6-mark question. So that means there's something that you still need to calculate by the side before you can calculate the speed. And if we can look at the diagram, we can see that it is obviously the displacement, because from A to B, we are not given the displacement. So what we can do now is to say that if we are to use our trig ratio sine theta, we want to have sine theta is equals to opposite over hypotenuse, which your opposite is your height, and then your hypotenuse is your delta x here. Now we have sine 30 degrees is equals to 10 over delta x. So to calculate delta x, we now have to say 10 over sine 30 degrees, right? Which means our delta x will now be equals to 20 meters, right? So punch it into your calculator. Remember, as you are watching these videos, you are having your notebook and pen and you are doing these questions along with me, so that you are not just watching the videos, but then you are proactive and gaining something, right? So, okay, now we must calculate the speed of the boy skateboard unit at point B. Now we have the displacement, and then we are going to opt for the formula, work done by non-conservative force. Then this is a change in EK plus change in EP. But then having to observe our free body diagram that we drew, we know that the only non-conservative force that we have is what? Is the frictional force, right? So Fk is the only non-conservative force. So that means we can replace here by Fk delta x. Okay, so do we have the value of Fk? Yes, 50 newtons. So Fk delta x and then cos theta is equals to what? Half mass Vf squared minus Vi squared plus mg, and then height finally minus height initially. Right. Then at this point, what we can do is just simply substitute into that formula. So we have Fk is 50. Our displacement we have already calculated 20, and then here we have cos 180 degrees. Remember, with Fk, the theta is always 180, since a kinetic frictional force does negative work. So we have half. The mass is 60 kg, the unit, and then Vf squared final velocity. That's what we are trying to calculate. But then the initial velocity, we're just going to assume that the boy at this point was just standing on the ramp, right? Was just stationary on the ramp. So the initial velocity would have to be 0. And that mass is what? 69.8. And then height finally, we have what? We have height finally will be 0 at that point, and then height initially is 10, right? So we have 0 minus 10. Now at this point, you just need to press your calculator. 50 multiplied by 20, cos 180, that will be negative 1000, and then is equals to half of 60, that's 30 Vf squared. Now, obviously, if we take this multiplied by 0, it's going to be 0. So we are left with 60 multiplied by 9.8, bracket 0 minus 10, right? So which will give us negative 5,880, which we then need to transpose over to this side. We have negative 1,000 plus 5,880 is equals to 30 Vf squared, right? So you punch that into your calculator, and then you are going to have 4,880 is equals to 30 Vf squared. Divide both sides by 30. We end up with Vf squared is equals to 162.66667, whole lot of 6. And then we can then square both sides. So square root the answer. We are going to have 12.75 meters per second, right? And that is the speed of the boy skateboard at point B, right? So obviously you need to save that value there, because the following question you might need to use it. So 12.75 meters per second. There we go, right? So now we have our 6 marks in the bag, and then understand the nature of a 6-mark question. We needed to calculate final velocity, but first we needed to find out the displacement. We needed to calculate the value of the displacement so that we can substitute into this formula right here, right? So that's always the nature of a 6-mark question. There is always a delay in terms of us having to calculate something else. Then 6.3 says point C is delta x meters to the left of point B. So as we can see there, the boy skateboard unit comes to rest at point C, right? So at point C, we are told that it comes to rest. So that means the final velocity at point C is 0 meters per second. Then we are told the coefficient of kinetic frictional force, mu k, for the surface BC is 0.15. Now for the surface BC, 6.3.1 says, state the work energy theorem. Now we have already discovered that whenever we want to write this definition, we just have to remember it from the formula. W net is equals to change in EK. And then we are going to say it states that the net work done, is equal to the object's change in kinetic energy, right? So that's it. The net work done on an object. So the net work done on an object. So we can even include that. The net work done on an object is equal to the object's change in kinetic energy. So the work energy theorem, meant to say, states that the net work done on an object is equals to the object's change in kinetic energy. Right, so 2 marks just like that. And then let's look at this 5-mark question. It says use the, so here we still have 12.75 meters per second. Let's not forget that. Use the work energy theorem to calculate the distance delta x that the boy skateboard unit moved before coming to rest at point C. Right. So remember, this is now a horizontal surface. And then with the horizontal surface, we know that we use the work energy theorem. So here, if in the statement was vouching for that, use the work energy theorem. So that means even if you wanted to use other formulas, you were actually prohibited from doing that, because this one is specifically saying use the work energy theorem. Right. So note that. So from here we have what? We have this. Then we can start by showing the free body diagram. That's the normal force. And then down here we have the gravitational force. And then to the side opposing the motion is our friend kinetic friction. Right. So now there is no applied force, because this is just sliding at its own accord. And then also here, no force is being applied. So it's just the skateboard and the boy moving freely just like that. Okay, so now we can say W net. So 5.3.2 W net is equals to change in EK. Now, obviously, we do know that the work done by the normal force will be 0 joules, and the work done by the gravitational force will be 0 joules, mainly because these two forces are what? Perpendicular to the displacement. So no work is done by forces that will be perpendicular to the displacement, meaning that the W net will only be represented by the work done by Fk, right? So it is the only force that will be doing work on this particular unit here, the boy skateboard unit, right? So we can then break down our WFK here to Fk delta x and then cos theta, which is equals to half m bracket vf squared minus vi squared. But then the trace mesh is that we are not given Fk. Instead, we are given the coefficient of Fk. So what do we do in this case? Whenever we are given the coefficient of friction, we need to always put it in the back of our minds that we need to calculate Fk, right? So we need to be calculating Fk on our own. And then looking at the free body diagram, we can see that this is case number 1 of your normal force cases, which I did cover on the video that I will also share on the end screen description. So for you to check it out, the Newton's second law, whereby I deal with the 4 cases of the normal force. So make sure that before you can do anything related to work energy and power, you actually check your Newton's second law, because remember, this is just an extension of Newton's second law. So you might fail to answer some of the questions because you don't know some of the concept from Newton's second law. So, okay, then here we know that normal force is equals to Fg. So that means if I wanted to calculate a kinetic frictional force, I would say mu k multiplied by n. But then the n here will be replaced by Fg, because we are saying that they are equal. Remember, Fg can be broken down to mass times the gravitational acceleration, which means I have 0.15 multiplied by the mass is what? 60, and then multiplied by 9.8. So now we want to punch that into our calculator. 0.15 multiplied by 60 multiplied by 9.8. And then when we punch that into our calculator, we get 88.2 newtons, right? So what are we going to do with this 88.2 newtons? We want to replace it here. right? So substitute here 88.2. And then what is our displacement? Remember, that's what we are looking for, right? We are not using the displacement that we found here because now we are dealing with point B to C. So the displacement is what we are looking for here, as we are being told, calculate the distance delta x. So this is delta x and then cos 180 degrees. We still maintain that 180 degrees because FK in every situation will be doing negative work. So this is half and then 60. We have final velocity is 0, comes to rest, remember? And then the initial velocity is the one that we got at B. Remember, what becomes the final velocity from A to B is now the initial velocity from B to C. So that's 12.75 and then square, right? So at this point, you need the 8 of your calculator. 88.2 cos 180, that's negative 88.2 delta x. And then you punch this into your calculator. That's 1/2 and then 60 and then 0 square minus 12.75 square, then close the bracket. So make sure that you punch in everything exactly as it appears, and then always double check. Guys, there are so many mistakes that always come with people punching their calculators. So every time you punch in a calculator, confirm, redo it again to make sure that everything that you punched in there is correct, right? So do not lose marks mainly because of computation error, right? So this is delta x and then divided by negative 88.2. Our displacement will be 55.29 meters, right? Awesome. So there we go. Now 5 marks in the bag, just like that, right? Nice one. Very interesting, right? So let's keep on pushing. Another question. So remember, you want to do as many questions as possible. You want to see different variations of these questions so that by the time you walk into your exam, it's time for you to write your exam. You are confident, right? You are ready for any question that might come because you have seen so many questions. This is more on exposure than it is on how smart you are. The more exposed you are into question papers, the better your chances of passing. It has nothing to do with how smart you are. You just need to see as many questions as possible. Then question 8 says, turbo of mass 70 kg slides down a playground slide that makes an angle of 30 degrees with the horizontal. When he reaches point B, he is at a height of 2.8 meters above the ground and has a speed of 0.35 meters per second. Now, if you can look at this question, it is similar to a question that we did previously on that was speaking about a passenger on an airport, Bloemfontein Airport. If you can look at that question and this question, they both have the same values. The mass of that passenger was 70 kg. The mass of turbo here is 70 kg. They said the initial velocity of the passenger was 0.35 meters per second. Also here, the initial velocity of turbo is 0.35 meters per second. Even the height, I think the only thing that changed here is the angle of the incline. For that other question, it was 40 degrees. For this one, it's 30 degrees. But I'm saying all this to make you note one thing. There is no new question that you will write. All these questions are just recycled, right? They are recycling questions, which is good news to you. If they are recycling questions, that means you have a better chance of passing, because if you can practice past exam papers, that means there is a chance that you can see something similar to what you did on your past exam papers, right? So capitalize on doing as many questions as possible. Then 8.1 says, define the term non-conservative force. What is a non-conservative force? We say is a force for which the work done in moving an object between 2 points depends on the path taken. Right, so that's it. A force for which the work done in moving an object between 2 points depends on the path taken. And that's basically how you define that. Now, a constant frictional force acts on turbo as it moves down the slide. Name a non-conservative force acting on turbo. What is that non-conservative force? Now, we already know it has to be frictional force, right? So, frictional force. Okay, that's it. And then, as we are being told here, a constant frictional force acts on turbo, then that means it's a giveaway. They had already given us the answer. The coefficient of kinetic friction of the surface of the slide is 0.112. If you can check, this is the same coefficient value that was also given. Then 8.3 says, calculate the frictional force that turbo experiences as it slides down from the slide from point B to C, right? Calculate the frictional force. Then obviously here, this is on Newton's second law. To calculate the frictional force, we need to say Fk is equals to mu k multiplied by n. But then again, on our cases, once this is on an incline, we know that the normal force is always equal to Fg perpendicular. So your normal force breaks down to mg cos theta, right? So note that this only happens if an object is on an incline, right? If the object is on an incline, then we know that the normal force is equivalent to the Fg perpendicular, which breaks down to mg cos theta, right? So again, check out that video on Newton's second law. So 0.112, and then here we have mg cos theta. The mass is 70. Multiply that by 9.8 and then cos. Now the theta that we are going to substitute here is the theta of the incline. Remember, we are applying Newton's second law. So the cos theta there is the 30 degrees. And then you're simply just going to take your calculator, 0.112 multiplied by 70 multiplied by 9.8 and then cos 30 degrees, right? So this is going to give us 66.54 newtons, right? Rounded off to 2 decimal places. And then just like that, 3-mark question usually means formula, substitution into the formula, and the correct answer with the correct SI unit, right? Okay, so save that. We have our Fk as what? 66.54 newtons, right? And then let's continue. Says using only energy principles, calculate the velocity of turbo at the lowest point of the slide, which is point C, right? Now note this, we are on an incline, and then on an incline, we normally vouch for what? Work done by non-conservative force formula, right? So we are going to have 6.4 is W and C is equals to change in EK plus change in EP. The only non-conservative force that we have is Fk, right? So here we are to determine what? Calculate the velocity. So we are going to have Fk delta x and then cos theta, since kinetic frictional force happens to be the only non-conservative force. And then this is half m Vf squared. So half minus Vi squared plus mg, and then height finally minus height initially, right? Okay, so now let's substitute into the formula. We have our Fk, which we did calculate, 66.54, and then our displacement is what? What are we looking for? We are looking for the velocity. And then do we have the displacement? Yes, we are told here 2.8 meters. And then again, if we are looking for the displacement, we're going to apply sine theta is equals to height over the displacement. So again, we have sine 30 degrees. So you see, now once you do as many questions as possible, you start to see that, oh, we are actually doing one and the same thing. Only thing that changes are the values, but then we are simply performing the same calculations here. Once you grasp the method, then you are gone, right? You know that, okay, whenever I don't have displacement, but then height and angle is given, then I need to come to this formula to calculate, right? Irrespective of the values that you are given, you are always applying the one and the same thing. So you can now calculate your displacement. That's 2.8 divided by sine 30 degrees, right? And then, okay, let's check. Our value becomes what? 5.6 meters, right? And then that's the one that we are going to use here, 5.6. Again, how many marks is it? It's 5 marks. 5, 6, 7. The nature of 5, 6, 7 marks is that you need to calculate something by the side before you can come and calculate with the formula that you are required to calculate with. So this is cos what? 180 degrees. At this time, you can even write this in your sleep. So half mass is 70, and then final velocity, that's what we are looking for, right? But then the initial velocity is 0.35. And then we have our mass is 79.8. And then our height finally, at the point when it reaches point C, height will be 0. But then at the point where it is above there, the height is 2.8, right? So we just grab our calculators, 66.54 multiplied by 5.6, and then cos 180 degrees. So this will give us what? Negative 372.624. And then half of 70 is 35. 35 multiplied by VF squared, that's 35 VF squared. Now, careful with this one. We are going to take what? All of this, half of 70, multiply by negative 0.35 square, right? So half of 70 is 35, multiply that by negative 0.35 squared. So be careful of how you actually punch this, right? So this is just one term altogether, and then which is going to multiply by negative of this square, right? And then negative 4, negative minus 4.2875. And then we can do this part here. That's 70 multiplied by 9.8. Here you can just punch everything all at once. So you're going to punch all of this and then also that inside the bracket, 0 minus 2.8. Now, if you punch all of that into your calculator, you get negative 1920.8, right? Of which at this point, you will need to add these ones, right? So more like adding them to the negative direction. And then this is negative 372.624 is equals to 35 VF squared. And then let's say negative 4.2875 minus 1920.8. This will give us what? Negative 1925.0875, of which you'll then need to transpose it over to the side. Remember, when it jumps over to the side, it changes the sign. The negative now becomes positive. So we're going to have negative 372.624, and then I'm just going to say plus 1925.0875. And then all of this will give us what? Will give us 1552.4635, which is equals to 35 VF squared. Now at this point, we can divide both sides by 35. Both sides by 35. Then our VF squared becomes what? That divided by 35, that's 44.3561. And then we can square both sides. So our final velocity becomes what? We square that. Final velocity is now 6.66 meters per second, right? And that's basically how you were supposed to approach that, right? So we have 5 marks in the bag, just like that. Okay, now let's now look at 8.5. That's a conceptual question. If the angle between the horizontal and the slide is increased, so that means hypothetically, let's say it's increased to like maybe 70%. So they say if the angle between the horizontal and the slide is increased, how will the change influence the frictional force acting on top, right? Only increase, decrease, or stays the same. Now we already know that if we increase an angle, frictional force has to decrease. So we say decreases. And then we say our explanation, an increase in the angle decreases the magnitude of the normal force. The magnitude of the normal force. Now, if you are Thomas, I will also show you the calculation. So I want to show you the before and after. So before, if we wanted to calculate our normal force, we'd just say mg cos theta. Now I want you to check this so that you are fully confident about what I'm writing here. So the mass is 70 and then 9.8 and then cos theta. That's before, right? So 70 multiplied by 9.8 and then cos 30 degrees. Our normal force is just only 594.09 newtons. But now the new one, which is after, let's say we increase. Remember, they said it's increased. They never said to what angle does it increase to. But then I'm just going to say hypothetically, let's say it increased to 70 degrees. So N is equals to mg cos theta. And then this is 70 multiplied by 9.8 cos what? 70 degrees. Now we want to check if the value really does decrease. As I'm explaining, 70 times 9.8 and then cos 70 degrees. And then I get that the value is 234.63 newtons. Now you can observe that the normal force really decreased. So increasing the angle and increasing the angle decreases the magnitude of the normal force. But then we know that normal force is directly proportional to the frictional force. Is directly proportional to the frictional force for a constant nu k, right? So for a constant coefficient of kinetic friction, which never changes, the only way you can change a coefficient of kinetic friction is by changing the whole surface altogether, right? So that means a normal force is directly proportional to the frictional force. Therefore, the frictional force will decrease as well. Right. So now our answer is decrease. Again, if you want us to prove, let's say before, Fk would be what? Nu k multiplied by n. So this would be 0.15 because we must maintain the same coefficient of friction. No, not 1.5. Now taking coefficient for the previous question. So 0.112. And the normal force is 594.09. So this is before. The frictional force is this, 594.09. And then we are only getting 66.54 Newton, which we did calculate. But then the new one, so after the increase in angle, we have Fk is equals to mu k multiplied by n. This is 0.112. And then this is 234.63. And then let's see the Fk now. 0.112 multiplied by 234.63. Then we find that the new Fk is now what? 26.28 Newton. So it is true that when we increase the angle, the frictional force will decrease, because the normal force is decreasing and normal force is directly proportional to frictional force. So if normal force will decrease, that means frictional force will also have to decrease. So remember, you are not required to show calculation for your explanation, right? I'm just out there trying to prove to you that even with calculation, it does agree with what I've written here, so that you have confidence in that, and then you have you know this beyond any measurable doubt to know that it is true, right? Okay, so that's basically that for 3 marks. That's how you were supposed to explain that question there, or that scenario. Okay, so nice. Let's look at another one. So let's do the last one for the day. This is a very interesting one. An object of mass 20 kg is released from rest. Note that released from what? From rest, meaning initial velocity was 0, and then at point P, which is 5 meters above the ground, it slides down the track and comes to rest at point B, which is 4 meters above the ground, right? And then the curved section PQ is frictionless. So frictionless here. Note frictionless. Whenever we talk about frictionless, what always rings in our mind, the energy principle, is principle of conservation of mechanical energy. The horizontal section QR is 10 meters long and is also frictionless. So all the way like that, it's frictionless all the way up until R. And then they say section RS now is inclined at an unknown angle theta to the horizontal and is rough. So here there is friction. The frictional force and non-conservative force between the surface and the object is 20 Newton. So here they're telling you that frictional force is a non-conservative force. We already know that, right? So 5.1.1, state the principle of conservation of mechanical energy. We are going to say it states that in an isolated system. So note that in these questions, we have already defined all the definitions that you might be required to define in exams. States that in an isolated system, the total mechanical energy is conserved. Or you will say it remains constant, right? So that's basically that. Then 5.1.2 says is mechanical energy conserved as the object slides from P to S, as it slides all the way from P. So is mechanical energy conserved as the object slides from P to S? Write down yes or no. So because they're also including all the way to S, we are going to say no, right? We are going to say no, because at this point, that's where we start to have what? Friction. But then if they had only mentioned from P all the way to R, we would say yes, mechanical energy is conserved. But now it's not conserved, because at this point, we can see that we are starting to have friction here. And then once we have friction, mechanical energy cannot be conserved. Now, the kinetic energy of the object at point Q is equal to that at point R. Why? Because here we know that since it's a horizontal plane, the object will be moving at constant velocity, right? Or the block will be moving at constant velocity, meaning the velocity at this point is equal to the velocity at that point, which then leads to the kinetic energy at this point being the same as the kinetic energy at that point. Now, 5.1.3 says, using energy principles only, determine the speed of an object at point R. So we know that obviously to point R, we have a frictionless surface, so we must apply mechanical energy. Mechanical energy at point P is equals to a sum of mechanical energy at point Q. So I'm going to calculate from point P top and then point Q bottom. Now I know that if I find the velocity at this point, that's equivalent to the velocity at point Q. So I will say this is mg h at point P, and then this is half mv squared at point P, which will be equals to mgh at point Q plus half mv squared at point Q. Now, what is the mass? The mass is 20 kg, and then G 9.8. Height at point P is 5, and then plus half. Mass is 20. Velocity at point P, remember they said from rest, so it has to be 0. And then mass is still the 20, 9.8, and then height at Q is now 0 because at that point it's on ground level. And then this is half. Mass is 20. And then what are we looking for? We are looking for the velocity at point Q. Now we have 20 multiplied by 9.8 multiplied by 5, which will give us what? 908. This one, all of it will just give us 0. And then also this one, all of it will just give us 0. And then half of 20, that's 10. So we have what? Equal to 10 v squared Q, and then divide both sides by 10. This will be 98, and then v squared Q. Then we can square both sides like this. Our VQ will become what? So square root of 98, that will give us 9.90 meters per second, rounded off to 2 decimal places. So it's almost like the value that we got in one of the questions here. Okay, so that's the value right there. And then in conclusion, we are going to say, therefore, also the velocity at point R is 9.90 meters per second. Because remember, kinetic energy in point Q and point R is the same. So the kinetic energy is as a result of the velocities being the same, right? Okay, so we are fine with that one. And then as 5.1.4 says, now explain the term non-conservative force. So once again, so do not be lazy to define, guys. If you want to save yourself time and energy to be busy wanting to memorize this just a day before you write, you can simply just be in a position whereby every time you're practicing your question papers, you write the definitions. In that way, you do not have to try to memorize all those definitions when it's about time for you to write tomorrow morning. But then in a way, you will already know that those definitions simply by repetition, because you have written them over and over again, right? So if you get to a point whereby you have written this definition 5 times, I think it's impossible to even forget it. So a non-conservative force is a force for which the work done in moving an object between 2 points depends on the path taken. So that's it. So a force for which the work done in moving an object between 2 points depends on the path taken. And that's basically how you define that. Then, okay, we have 5.1.5 says, calculate the magnitude of the angle theta, right? And then how many marks do we have? 6 marks. So note that here we don't have theta, right? And then even if we were trying to calculate the displacement, we are also not given the displacement for this point, right? So at this point, we need to consider sine theta is equals to h over delta x. In order to find theta, we have to know both the height and the displacement. So looking at this question, this is a 6-mark question. The nature of a 6-mark question is bound to say that we need to calculate something else before we can get to what we are actually looking for. So here we understand that what's actually stopping us from calculating theta here is the fact that we don't have the displacement. The height is there, it's 4 meters, but then the fact that we don't have the displacement, that makes it impossible for us to calculate the angle. So what is the mission right now? The mission is to calculate delta x, so that when we find delta x, we can then be able to use this formula right here to simply just calculate the what? The theta, right? So understand the question. So now we have 6.1.5. What are we going to use? This is an incline, and then we know with an incline we vouch for which formula? WNC is equals to change in EK and then plus change in EP, right? Now, the non-conservative force that we obviously have here would be Fk, right? Frictional force. And then we can break it down to Fk delta x and then cos theta is equals to what? Half m Vf squared minus Vi squared plus mg and then height finally minus height initial. Now plug and play. Let's substitute. Remember, we are told that the frictional force and non-conservative force between the surface and the object is 20 Newton. Note, a non-conservative force, which is also a hint from the examiner that we should use non-conservative forces, because we've been speaking about that non-conservative force, which is only frictional force in this case. Then, okay, we have the 20 and then our displacement. That's what we are looking for. Before we can find the angle, we need to find the displacement. So this is cos 180 degrees and then half. The mass is 20 as well. Okay. So note that we have 20 kg and then the 20 here was for the 20 Newton. So do not think it's one and the same thing. Then Vf, remember at this point it comes to rest, right? So it goes all the way and then up until it comes to rest at point S. So it's going to be 0 square. And then the initial velocity is the velocity that we got at point what? At point R. Remember here we got 9.90 meters per second, which you said will be equivalent to that since it's moving at constant velocity. So that's 9.90 square. And then plus the mass 20, 9.8, and then height finally at that point when it reaches that height, it's 4, and then initial it's 0 because at that point it was on the ground level. So that's negative 20 delta x. You punch all of this into your calculator. That's 1/2 bracket 20 close and then bracket 0 square minus 9.90 square close bracket, then plus 20 multiplied by 9.8. Please punch this along with me and confirm if I find the correct answer. Right, so if you find this answer, that's negative 196.1. And then we can divide both sides by negative 20. And then our displacement delta x is supposed to be what? So we punch that. We are going to get 9.805 meters. But now do not get carried away in the question. Remember that you are not done. There is just one step done, but then we are not complete, right? So we have sine theta is equals to h over delta x. Now our height is what? 4 meters. Our displacement 9.805. Then we are looking for sine theta. So we can leave the theta here. Arc sine, as you know from your trigonometry, 4 over 9.805. And then we have theta. Arc sine is 4 divided by 9.805. Close bracket. And then this is going to give us what? Our theta will be 24.08 degrees, right? And then that's basically how you were supposed to calculate all of that. Very nice question, very interesting. Then 5.2 says, at a construction site, a 100 kg block is lifted upward at a constant speed, right? Constant speed. Now, what comes into our mind? Acceleration is 0 meters per second square. As a result of that, F net is 0 Newton. As a result of that, W net is 0 joules. As a result of that, change in EK is 0 joules. So these are the things that you are seeing as a physics learner whenever they mention the keyword constant speed or constant velocity. So a constant speed of what? 0.1 meters per second. So also it means that the V initial is equals to the V final, which leads to our change in EK being 0. Now 5.2.1, define power, right? So what is power? We say power is the rate at which work is done. At which work is done or energy is dissipated. Right. So the rate at which work is done or energy is dissipated is known as what? Power. Right. Now, 5.2.2 meant to say, calculate the average power delivered by the crane while lifting the block upwards. Right. Now, the formula that we can apply, we have two formulas, power, W over delta T, or we have the one for P average, which is F multiplied by V average, right? Now, we can calculate with either formula, but then what I'm going to apply is Newton's second law. And then since they said a constant speed, constant velocity, I can simply say, let me calculate the force applied, right? Having to draw my free body diagram, I know that this will be the force of the cable, and then right here, which can be referred to as tension as well. And then this will be Fg. But then since it's constant speed, we know that forces are balanced. So this will be equivalent to that. So if I want the force of the cable, which is the force applied, I would simply say Fa minus Fg is equals to what? Ma. So starting with Newton's second law, I obviously need to say F net is equals to what? Ma. Then this is force applied minus Fg is equals to mass. Acceleration is 0. So there we go. So this is Fa. M multiplied by 0 will be 0. So Fa. So let me say Fa minus Fg will be equals to 0 as a result of the multiplication of M and 0. Then that means force applied is equivalent to the gravitational force. Then if I want to get the force applied, I will just say mass times the gravitational acceleration, which is the 100 multiplied by 9.8. Now let's see what it gives us. So that is going to give us 980 newtons. But then now to calculate the power average, I will just say P average is equals to 980, which is the force, and the average velocity will be that constant velocity that we are given, which is 0.1. And then if we say 980 multiplied by 0.1, we get 98 watts. So that's it. For 3 marks, that's all you needed to do. So your average power becomes 98 watts, right? So, okay, even if you wanted to use this one here, it would be quite impossible for you to use it because, as you can see here, we are not given delta time. So, which is why we did not use this one. So, we didn't use this one because we were not given delta time. However, if you want to use that, that means you would have to calculate delta time on your own, right? So, of which might be possible or might not be possible. Okay, so it might be possible with equations of motion. So, but then that is a pretty long stretch for a 3-mark question. So I guess the easy way out to deal with it was just to consider P average is equals to the force applied multiplied by the average velocity, since we were already given a constant velocity of 0.1. Okay, so that's basically how we deal with these questions. So that was for 21 marks. So it was a pretty long one, but then interesting as well. So, okay, guys, just make sure that you come back to these videos, watch it as many times as possible, and just try to understand the approach that I took into solving all these questions here. But then with all that being said, you know what to do. Share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.